Writing and interpreting reports is an important skill for anyone interested in data visualization. That's why I've decided to create a course that focuses exclusively on building dashboards. Now let's run through the topics we will cover in the coming lectures. We'll begin by discussing the main principles in data visualization. We'll examine the color theory, and we'll get to know how to choose the right visualization based on your data. Then we'll dive straight into dashboard building. During the course, we'll work on a real-world case scenario and produce a report for a large company operating in the fast-moving consumer goods industry sector. We will build our report from scratch, so you can follow along as we move forward. By the end, you will see how all the pieces of the puzzle fit together. Not only that, but we've also created a report on two distinct platforms, Excel and Tableau. Building a dashboard in Excel will be more technical, as the software hasn't necessarily been built with such dynamics in mind. Nonetheless, it is one of the most widely used software across industries, hence, know-how in creating dashboards in Excel is a value-added skill. The second platform we've chosen to showcase is Tableau. Unlike Excel, creating a dashboard in Tableau is rather intuitive. No wonder, after all, the software is specifically built for creating such dynamic visuals. For both platforms, we've dedicated a separate lecture on dashboard styling and interpretation. In the styling lecture, we'll introduce our own custom color scheme based on 365's colors. We've worked with our senior graphic designer to ensure that the design of the custom theme is up to the mark. The final lecture is about interpreting a report. The ability to gain actionable insight from the dashboard is possibly the most valuable competency you'll acquire throughout the course, and we're confident that you'll be able to apply this knowledge to your future projects without any difficulty. The techniques you will learn can be used to solve a number of problems, either with Excel or with Tableau. We want to help you acquire technical and interpretation skills that will make you the hero of our organization. Among all the benefits of the course, its integrity is what makes it so extraordinary. Our goal is to deliver the ultimate training experience for you. Don't hesitate to post in the Q&A if you have a question to ask or simply want to share something with the community. Time to buckle down and let's get started. Hi, and welcome to our first lecture. Since you enrolled in this course, I can imagine you have your own arguments about why learning data visualization is important, which is the first and most essential step on your data viz journey. Nonetheless, there are several different reasons that I'd like to highlight before really diving into data visualization. People have biologically evolved to be visual creatures. In fact, eyesight started developing 500 million years ago, a long time before the first human or even dinosaurs came about. Supposedly, it was the big trigger for the development of complex life forms. Not only that, but it proved exceptionally useful. Nowadays, around 96% of animal species have developed eyesight, and no wonder. From a survival standpoint, being able to see is surely an advantage. It can help predator detect its prey and vice versa. It could mean a narrow escape from the jaws of death. Being so important, seeing has become one of the most important and energy-consuming activities, and we use it for a variety of activities, not least for visualizing data. Okay, maybe that's not the main purpose, but it truly helps in business and data science in particular. And while our eyesight is completely amazing, it's not sufficient to appreciate the beauty of raw data. In fact, many people look at numbers and see nothing. This is not shameful. On the contrary, being able to see the data is an extraordinary feat that only robots ought to possess. But that shouldn't be the case. Enter data visualization. Data visualization is the field which enables people to see the numbers. And the person who visualizes the data is the enabler. They are the imperative person in an organization who helps others see the numbers. Sounds powerful, but there's more. Needless to say, data and data science are a leading force in today's economy, and being able to gather good data is crucial. Being able to pre-process it is another key ability, which in turn allows us to do predictive modeling, machine learning, and other amazing data science activities. However, There is nothing more important than being able to interpret that data. Data interpretation could be based on the pre-processed data and provide insight on its own. Or it could be just a supporting step in a bigger project, such as building a machine learning algorithm. Either way, no matter what you do, you will always end up in need of visual representation because our brains take in and process visual information the fastest. Okay, this leads us to a key question. Who are these visualizations intended for? Well, it could be you, as in the examples above. Often it could be your colleagues or managers. Depending on your line of business, it could also be your clients. If you're not doing the visualization for yourself, it is highly likely that your audience would not be super technical. On the contrary, they will be people whose job is to make strategic decisions based on your visualizations. It is quite possible that they would never explore the underlying data if you had not visualized it. Therefore, data visualization is the face of data science. There may be hundreds of human hours behind gathering and pre-processing the data. However, the key decision makers in a business are likely to only see and trust the data visualizations. As the person who will visualize the data, you are extremely privileged. You are the one who curates and censors the data. Your audience will see and make their strategic decisions based on your visualizations. Therefore, you should also recognize the responsibility and care with which you must approach this course, and your data visualization career as a whole. Your work may lead to the success or the failure of your organization. But don't worry. The good news is that you are not the only one who realizes the importance of data visualization. One thing that points to that fact is that there has been incredible progress developing a plethora of visualization tools that you can employ. Excel, Tableau, and Power BI are just some of the software used on a daily basis for data visualization. On top of that, Python and R, the leading programming languages in data science, have outstanding data viz packages. These have enabled the popularization of complex charts unavailable elsewhere. So even if you are not very confident in your skills at this point, the technology is on your side. All right. Finally, data visualization is definitely not boring. Quite the opposite. Visualizing a dataset could be spectacular. Apart from a technical person who helps others see, you can also be an artist. You can play with shapes and colors to make the data more vivid. You can emphasize certain parts of a chart to gain the attention of your audience, or you could intentionally deceive them. You choose to be the good guy or the bad guy. Without luring you any further, I think you're starting to understand why data visualization is so important. Career-wise, your data visualization skills can ensure your spot on the strategy team in a company. If you create the charts and the dashboards that help others see, you will be an indispensable part of any team. So let's not waste more time on the why and focus on the how. Starting from the next lecture, we will actually start learning. See you there, and thanks for watching. Welcome back to the data visualization part of the course. As with any important topic, let's start with some theory. The process of visualizing data usually involves the following steps. First, you get some data. For simplicity's sake, let's assume the data is already pre-processed and ready to be visualized. Second, you choose the right visualization. Third, you actually visualize the data and then style and label the chart. Each of these steps is challenging on its own. However, in this course, we will not focus on the first one. Instead, we will work with pre-processed data sets ready to be visualized. The third step will be explored in detail in the upcoming sections. It is the meat of the course, as they say. In this lecture, we will focus on the second one, how to choose the right visualization. Choosing the right visualization is like riding a bike. It looks like an insurmountable task in the beginning, but once you get comfortable, it becomes a reflex you cannot forget. I like to say that I don't choose the most appropriate chart anymore. The most appropriate chart chooses me. By the end of this course, you'll be able to say the same, I hope. But before we develop that data viz muscle memory, let's talk theory. We at 365 really like using frameworks. Approaching data visualization is no different, and there is more than one successful framework when it comes to choosing the correct visualization. It all starts with the mother of data science, statistics. In statistical theory, we often talk about types of data and levels of measurement. Quite often, these determine the chart we choose to plot. Okay, let's quickly explore the types of data. There are two types of data, categorical and numerical. Categorical data describes categories or groups. One example would be car brands like Mercedes, BMW, and Audi. They show different categories. Another instance of categorical variables is answers to yes and no questions. For example, if someone asks you, "Do you own a car?" Yes and no would be the two groups of answers that can be obtained. All right. Numerical data, on the other hand, as its name suggests, represents numbers. Without diving deeper into that, examples are the count of objects. For instance, 5 bottles, 3 glasses, 1 table, or 7 cars. Other examples of numerical variables are age, money, height, area, distance, and so on. We can continue like this until tomorrow, but how does this help us to visualize data? Well, knowing whether our data is numerical or categorical could actually guide us towards the appropriate chart. For instance, a bar chart contains several bars or several categories. Therefore, when using a bar chart, you will definitely have some categorical variable which is represented by each bar. Then there will be a numerical measure to show how high these bars will be. How about a pie chart? It's quite similar. There are several categories and some numerical measure to show what portion of the pie is attributed to that category. What about a scatter plot? It seems like both axes show numerical values. Therefore, to have a scatter plot, you need two numerical variables that are plotted against each other. Overall, the statistical theory is extremely useful for data visualization. However, it is also quite lengthy, so we have prepared some readings after this lecture on the topic. What is important for you during this course is to develop your data viz intuition based on these theoretical frameworks. Okay, let's do one more. What about a line chart? Looks like one axis is numerical while the other is a date. A date could be either numerical or categorical depending on your definition. Neither a good option, thus there is a whole field regarding such data called time series analysis. So our initial framework of dividing data into categorical and numerical proves to be insufficient. It is still a great basis, though. As someone who deals with data visualization, I've seen many other frameworks. The best one I've stumbled upon is provided by Data2Viz, and I'd like to quickly introduce you to it. They start with the question, what kind of data do you have? The possibilities are numerical, categorical, numerical and categorical, maps, network, and time series. Then there is a decision tree that guides you to the proper choice. You will quickly notice that this framework is based on the concepts we introduced just a minute ago. Nevertheless, they do so in a smart way, which is not completely restricted to data types. Another useful functionality of Data2Viz is that if you click on visualization, you will see additional information about it. But I believe you can dig into that on your own. So instead, I'd like to turn your attention to one extremely important observation. There is never a single possible chart choice. In reality, there are different ways in which you can visualize the same relationship. Moreover, the same chart could be used for different types of relationships. So how do we choose? Well, in general, you should never choose the most complex of plots. On the contrary, you should keep things simple. Many times I've seen charts that look intimidating or complicated. Upon closer examination, these charts usually turn out to be too confusing and can often be misinterpreted. Remember that you visualize the data for your audience. If you believe they may not understand a given chart, don't use it. The goal of DataViz is to help others understand data, not confuse them even further. With that in mind, if a bar chart can do the job, by all means, use a bar chart. You'd be surprised how often a bar chart does the trick. You may think that is too rudimentary, but a well-executed bar chart is a mark of a DataViz whiz. Great. We can now proceed with our next topic, color theory. Thanks for watching. Welcome back. So far, we spoke extensively about the development of eyesight and our ability to see the numbers through data visualization. However, when we think about eyesight, there is one characteristic of major importance we did not mention so far. Most of us have the ability to see in color. In fact, color can greatly change how we perceive information. That said, each person has a different perception of color, and I'm completely sure that you have had a fight with someone over colors at least once in your life. You may remember the striped dress from a few years back that had the online community in uproar. Was it white or was it blue? Well, it rather depends on our perception of color, or more precisely, it depends on the light. Without getting too technical about it, it's the light reflected from the object's surface that our eyes detect. And it is this light that our brain then translates into color. So what we determine as a particular color has much to do with how much light falls on the object at this moment in time. But perhaps more interestingly, it also depends on the interpretation of our brains, which can differ widely from one person to another. As you're probably aware, some people see a greater spectrum of colors compared to others. Then, there are also colorblind people who have a more limited perception of color. 5 to 10% of the human population suffers from some level of colorblindness. Therefore, it is extremely important to keep that in mind when talking about data visualization. Okay, with this new information, there are 3 important aspects we'd like to emphasize in this lecture. First, colors could be used to emphasize part of the information or even convey extra information. Second, colors can be used to enhance the appearance of our chart. Third, colors should be chosen carefully. All right, let's start with the most important one. Colors can be used to convey extra information. Here's a bar chart showing information about the financials of a company for the last 3 years, as well as for the next 3 years. The historical information is in the same color, while the projections for the future in a different one. This distinction is quite important as these bars are facts, while these estimates. While this information was available in the labels, we have also used color to emphasize that. In this way, we ensure that our audience will read our chart correctly. So you see, color could be used in a chart to speak to you. Fantastic! Apart from informational, colors have another important purpose. They can be used to draw our attention. Most of the time we use them with this purpose exactly, to make our chart stand out more. But in a nice way. One that the audience will enjoy and find visually pleasing. While I don't need to convince you of that fact, please look at this fellow. The colors on this creature are truly magnificent, and with reason. This is a mantis shrimp, the creature that practically sees 3 times more colors than a human. It's here to tell us that colors can aid your presentation tremendously. They can turn it from a dull shrimp into a glorious creation. So coloring your charts appropriately is very important. Thanks, mantis shrimp, for teaching us that. However, there is something else that we can learn from the mantis shrimp. Scientists suggest that although they see 3 times more color than us, they are actually worse at differentiating them. The point is, too many colors is not always a good thing. And in fact, when talking about data viz, less is more. So if you take away one principle from this lecture, it is that using more than 3 colors in a chart is simply prohibited. Usually going for 2 colors is desirable, but a 3-color scheme is the upper limit. Good, I'm sure you will remember that and stick with it throughout our work together. So we reach the third important part of this lecture, how to choose colors. Let's take a step back. There is an intersection of art and science called color theory. To work successfully with data visualizations, it is completely mandatory to be familiar with color theory. Nevertheless, it is not essential to dive too deep into it, so let's just quickly explore its basics. The 3 primary colors are red, blue, and yellow. All the rest of the colors could be created from a combination of these 3. Red and blue makes purple, blue and yellow makes green, and yellow and red makes orange. The newly created colors, purple, green, and orange, are called secondary colors. Obviously, we can repeat the same operation and mix each 2 of the colors on the screen together. The new colors that we create are called tertiary colors. The overall diagram that we get is called a color wheel. You can create all these colors using a paintbrush at home, and I'm sure you've already done so as a child. Continuing with color theory, we've got hue, saturation, lightness, shade, tint, tone, temperature, and more. But let's stop here. All of these color theory fundamentals are crucial for an artist or a designer, not for a data person. And here's the problem. First, if we create graphs and charts for a living, we are not designers. We could be artists of sorts, but generally, let's face it, we are no Picassos. We should be displaying data with charts, not picking colors all day. Second, computers don't generate colors based on red, blue, and yellow as in color theory. Instead, screens such as TV screens and computer screens rely on mixing light, and the main colors are red, green, and blue, coining the RGB color scheme. Moreover, most printers actually use the CMYK color model, which introduces yet another level of complexity. So knowing all that is all well and good, but it's not too helpful in terms of data viz. When creating a chart or a dashboard on the job, we simply want to choose a good color theme. And while all that color theory sounds fun, choosing your color from the color wheel is simply too time-consuming. So what do data viz people normally do? Well, there are 3 general cases. The first one is when your colors are predetermined. Say you are working with 365 data science as I am. If I were to make some graphs that were intended for the 365 team, I'd normally go for the 365 color. In this way, my charts will immediately relate to the audience and will appear very professional. In fact, quite often a company's colors dictate the styling of the data visualizations. Okay. Second, there are online tools that can help. Coolers.co is my favorite. I've been using it for years. Once you enter their website, you can click Start the Generator, and there will be a 5-color palette for you to enjoy. Pressing space, we get a different palette. Space again, 1 more palette. You can generate as many palettes as you like. The best thing is that you can actually lock 1 or more colors, and then clicking space would generate beautiful palettes revolved around the locked colors. I won't spend any more time on that. I just want to note that from the home page of the website, you can also explore trending palettes. These are some pretty neat color combinations, so you can bookmark that URL for future use. All right, one more thing, and we've saved the best for last. We know that even with color palettes at your disposal, it is not always easy to pick the best colors. That's why we have decided to use a different color scheme for each section of the course. We have carefully picked the colors for each chart draining from our work experience. This will essentially provide you with a dozen templates that you can confidently use later on in your career. Fantastic! Hope this helped, and thanks for watching. Hello everyone! In this part of the course, we will learn how to create a dashboard from scratch, a fairly advanced tool because it requires you to blend business understanding and technical capabilities. First of all, let's spend a few moments and discuss what dashboards are and how executives use them in the business world. A dashboard is a type of report, which is most often used in business and provides information about a certain aspect of a company's performance at a glance. It can be used to track a variety of corporate functions, such as sales and supply chain, to name just a few. Building a complete dashboard is one of the most important steps in your data visualization journey. The reason for this is that it is a complex tool, which is very versatile. It is also very powerful in terms of the volume of information that can be presented on a single page. This probably wouldn't come as a surprise to you, seeing as you're taking a course on data visualization, but one can use many different software tools to create a dashboard. For example, Tableau and Power BI. Both have gained increasing popularity among analytics practitioners due to their easy and intuitive interface. In this section, we'll build a report using Excel's capabilities, which will require a few additional technical steps. So let's spend a few moments here to discuss why it's worth learning how to create a dashboard in Excel. First of all, this will improve your Excel skills immensely. Moreover, Microsoft Excel continues to be the most popular tool in the business and finance world to this day, as many companies prepare their reporting in Excel. Therefore, it's a skill that is highly demanded. But not only that, we'll also see how to create the same dashboard in Tableau as well, a software which is designed with the purpose of creating of such dynamic reports. All right, hope you're as excited as I am. Let's continue with an overview of the task at hand. We'll explore the dataset in more detail in the next lecture. For now, what is important to know is that we'll be working with data from a company called Drinko. Drinko operates in the fast-moving consumer goods industry, also known as FMCG. The FMCG industry involves the production and sale of non-durable goods, such as soft drinks, toiletries, and processed foods, for example. It's well known for its high volumes and low margins, and the level of competition is typically high. Think about the soft drinks market. Sure, the two market leaders that come to mind might be Coca-Cola and Pepsi, the absolute giants in the industry. But if you try to recall your last visit to the supermarket and think about the water and soft drinks aisle, you'll realize there are numerous other brands. This is precisely why we've chosen this type of company and this product. For an FMCG business, it's extremely important to understand which are their most profitable products. What drives their customers to pick one product or another? What is the optimal size of the item that clients prefer to buy? These are precisely the questions our dashboard will help to answer. First, though, we need to get more specific and examine the dataset for this task in more detail. You can download it from the resources available with this lecture. See you soon, and thanks for watching. Again, before we start creating the necessary components for the dashboard, let's examine the data we'll be working with. The spreadsheet you see on your screen represents a data extraction that is typically obtained when working with a so-called ERP system. ERP stands for Enterprise Resource Planning. These are integrated software solutions that a company uses to collect, store, and manage data recorded as a result of business activities. Therefore, ERP systems are data warehouses, something like a container that collects the entire information of a firm. The two most popular ERP system providers in the world are Oracle and SAP. The extraction you see here has been made in SAP's Business Objects application. Business Objects is a tool that allows you to extract data that has been stored in the system. The data is naturally downloaded and used in Excel by the firm's financial analysts. As you can see, every row of the extraction contains specific descriptive and financial information. In the left part of the sheet are the so-called descriptive fields, showing descriptive information like the material number, description, the period when this occurred. Then we have the relevant brand, size, pack, client, and client type for the specific row. On the right side is all the financial information we will need in this exercise. It starts with volume, the amount that was sold per each of these lines. In our first example, this shows that 206 units of Crocky 250 milliliter 4-pack were sold in Kroger supermarkets in January. In the same way, going to the right, we have gross sales and discounts. It is a common practice that clients receive different discounts based on the amount of business they generate. This is a really important item because the size of discounts has a direct impact on the price that a client, a supermarket chain for example, can offer to its customers. Going to the right, we can see the various financial measures. Gross sales show a firm's hypothetical revenues without any discounts. If we then consider the discounts that had been given to clients, we will arrive at net sales. On the right side of the table, we have 3 additional cost items: cost of goods sold, distribution and warehousing expenses. Quite intuitively, cost of goods sold shows how much was spent to produce the product. Distribution and warehousing are 2 items that are often grouped together. Distribution is the transport expenditure that has to be sustained to deliver a product to a client. Warehousing indicates the cost of keeping the item in the company's storage facilities until the item is delivered to clients. Okay, now that we have an overview of our data source, we're ready to proceed and start working on the design for our dashboard. Can't wait! See you in the next lecture. Welcome back! When building a dashboard, it's always a good idea to start with a sketch of what it will look like. Even better, it is a great idea to show the preliminary sketch to a line manager or to the colleagues you are building this tool with. In this way, you'll be able to get them on board or amend the structure before you've done any actual work on the computer. So far, we've discussed the contents of the dashboard we want to build in this particular situation. So let's do that now, shall we? We know that the data we'll be using comes from an FMCG company. When analyzing this type of business, it's important to understand volume sold as well as the characteristics of the products that have been sold. At the same time, understanding profitability and its development over time are just as crucial for the business. In our case, we're looking at a B2B model, which means that the firm's clients are other businesses. However, it will be highly beneficial for Drinko to understand the needs of end customers too. For instance, they will be interested to gain insight into the client's preferences in terms of product size or brand. This is why in our dashboard, we'll incorporate information that will allow us to track customers' size and brand preferences. At the same time, we'll be able to observe the development of financials such as sales, gross profit, and discounts. Great! To display all of that information in our report, of course, we'll rely on different charts. First of all, we'll have a bar and line combination chart. This chart will help us track monthly net sales and gross profit development. Next, we'll follow up with an inverted columns chart. Here we'll show the volume of purchases by product size. This will allow us to understand how popular products of a particular size are for any given brand. And the third chart in our dashboard will be again of the inverted columns type. This time around, we're tracking the volume of purchase by client type. Remember, Drinko sells B2B. Therefore, they'll be interested to see whether their clients are supermarkets or discounters, for example. Lastly, we'll include 2 key performance indicators, one for the average distribution cost and a second for the average discount that has been given to clients. Now let's take a look at perhaps the most important feature in our dashboard. It needs to be dynamic. This means we need to insert a specific type of filter that allows us to examine a particular category of interest. That's why in Excel, we'll use slicers, which are the filters connected to pivot tables in Excel. Slicers allow us to filter for a specific brand. But what's important to remember here is that slicers do not alter our original data. All they do is filter it. so we see only a fraction of the data based on the selected condition. Okay, for our own report, we would like to filter our data based on the time of reference. This means that we'll need a field showing the current period we're in. This is extremely useful as the dashboard will be updated monthly, so we must ensure that this is a flexible tool that allows us to analyze different reference periods. The current period, as the name suggests, shows the month we're in at the moment, or the last month for which we have data. But this current period will not be fixed. Instead, we'll be able to go back in time and check the data as far back as we have information. But hold on to your hats, that's not the end of it. We'll also include an additional feature, which will allow us to transition between two separate reference periods. The first period is called year-to-date, or YTD for short, while the second is called last 12 months, or LTM. Let's explore the two in more detail. Year-to-date, as the name clearly indicates, shows the months that have already passed in a given year up until the current period that has been selected. So if our current period is June 2020, our reference period will start with January 2020 and end with June 2020. When we select this option, our data will be filtered and will display charts and numbers only for this period in time. This type of display is extremely important and useful in terms of marketing, for instance, to check whether certain quotas are being met, or to check if you're above, at, or under budget up until a given moment in time. Being able to compare data on a month-by-month basis and track year-to-date performance can be very convenient in a dynamic corporate setting. And how about our other period, the last 12 months? Here, when we choose our current period as June 2020, we'll observe the 12 months before June 2020, starting with June 2019, followed by July 2019, and right up until May of 2020. Here you might think, well, why don't we just look at a calendar year, say 2019 or 2020? Why do we need the last 12 months? Well, the truth of the matter is that for some businesses, especially the ones that are growing very fast, a lot can change in 1 year. So we want to be able to see financials for the last 12 months and not data, which is older than that. And what's more, the past year does not necessarily reflect the last calendar year. Say a company was founded in August 2019, then checking the numbers for the year 2019 wouldn't make as much sense. But if we're in August of 2020, the company will have 12 months of data and hence an idea of its annual revenue for the last 12 months. All right, hopefully I've managed to convince you how valuable it can be to filter the data in such a way. But there is one more filter that will help us analyze the company's performance: the brand slicer. By adding it to our dashboard, we'll be able to track the sales of each of the 16 brands of drinks for our company. This is quite fundamental, as it will allow us to understand if a brand is doing well, whether it's growing as expected, and how it performs compared to the other brands. Very well. Now that we've got our game plan, we're finally ready to start the actual work in Excel. See you in the next lecture. Again, we've already opened the Excel file containing the source data, and we can start creating our dashboard. Now, an important aspect to consider is that a dashboard is dynamic. Ours in particular will change according to the time frame chosen by the user. Hence, our data will reflect the selection that has been made. Unfortunately, things won't be very simple when it comes to execution because Excel isn't necessarily built with such dynamics in mind. No worries, it just means we must aid it a bit in that respect. In other words, we'll need to create additional features in our data to reflect the change in the period we're examining. So let's see how we can achieve this. We'll require 4 new calculated fields. They are date, current year, YTD, and LTM. These fields will be based on the current period and on the comparator we've chosen, so YTD or LTM. All right, let's begin by adding a date column to our data. This field will show the current month and year. Here we'll make use of Excel's date function. It requires 3 inputs: month, year, and day. For year, we require, the year. For month, we'll put the month value in the same row. For the day, we put the value of 1. The day is irrelevant in our case, as we'll be examining monthly and not daily data. Nonetheless, we must include some parameter, hence we pick the 1. Okay, nothing groundbreaking so far. Let's fill the entire column by copying the value in cell C1 and paste it for the remaining rows in the table. Excel will update the formula and show the correct values for each column. Thanks, Excel. Okay, one last tweak before we move on. We'd like our date to appear in a different format, showing the month first and the year afterward, omitting the day. To adjust the format of our cells, let's first select the entire column. Then we navigate to the Home menu and expand the drop-down menu here. For more number formats, we go to the last option, which is Custom. Let's scroll down and select the month-year format. This format will give us a 3-letter abbreviation for the month and a year denoted by 2 numbers. Let's try it out. Excellent! These are the values we'll use for our current period drop-down table. Speaking of which, we already have the necessary information to create it. Great! The first step is to copy the values in the column and paste them in a new sheet. Let's rename it to References to make sure all sheets have descriptive names. From here, I'll click on the Data tab and select Remove Duplicates. With this action, we'll have unique values for each distinct period, as all the duplicate values are going to be removed. Now we continue onto a new sheet, where we'll create our actual dashboard. Excellent! To select our current period, we'll use a drop-down menu. It will allow us to choose the month and year that will serve as the period for which we performed the analysis. To create a drop-down menu in Excel, we'll go to the Data tab again, and we'll select Data Validation. From the first drop-down menu, we choose List. Then, in the newly appeared Source field, we select the cells in the reference sheet that contain the individual dates. We confirm with OK, and great job! Now we can select our current period. In the next lecture, we'll include a reference period as well in the form of radio buttons. See you there, and thanks for watching. Welcome back. The next step in building the Excel dashboard is to include a reference period. You remember, the 2 options we want to consider as a reference period were year-to-date and last 12 months. For our presentation, they'll take the form of radio buttons, and we'll be creating them shortly. First, though, to create radio buttons in Excel, you need to make sure you have activated the Developer tab. Excel usually hides Developer when you've applied default settings. However, you can resolve that quite easily. Just go to the top Excel ribbon and right-click on it. Then, let's opt to Customize the ribbon. Here you need to make sure that the Developer tick is selected. Once you confirm with OK, you should be able to see the Developer tab in your Excel ribbon. Let's go ahead and open the Developer tab. Here, under Insert, we're able to add a radio button. So far, so good. We'll need 2 radio buttons in total, one for year-to-date and one for last 12 months, right? While we're on the topic, let's adjust the names. Right-click on a button and select the Alter Text option. The first button will represent the year-to-date, or simply YTD for short. The second button will be renamed as LTM, which stands for the last 12 months, as we mentioned earlier. All right, here comes the most important part, linking the two buttons. To link radio buttons, we right-click on a button and select Format Control. Then we choose a cell link. The cell itself is irrelevant as long as it's empty, so let's go with cell A1 from our references sheet. We perform the exact same steps for the second button as well. Importantly, we link it to the same A1 cell in the references sheet, thereby linking the two. Cool! Let's check on our progress. Now, if we select one button and check the references sheet, we can observe that the number 1 has appeared, showing us we're using the first button. If we select the second button, we'll see the number has changed to 2. Excellent! Later on, we'll be linking the radio buttons to our data, which will make them functional. But first, we have some additional work that involves adding a few extra columns. And we'll get straight to it in the next lecture. See you there, and thanks for watching. Welcome back. To create a dashboard that allows us to choose from 2 distinct reference periods, we have to add new fields to our data. This will enable us to update the data source every time the user selects a different reference period. But even more importantly, it ensures that our data is updated and showing the correct values. First, let's fill the current year. We simply take the year from our current period in the dashboard sheet. Let's just make sure we fix the cell by row and column to make sure it won't change when we copy the formula to the remaining cells in the columns. We just add a $sign before the column and the row, and let's try it out. Okay, great. And now we can move on to adding the remaining columns. All right, we need 2 columns, one for year to date and another for last 12 months. Let's begin with the former. The values in this column will show whether the data in a particular row should be included as year-to-date data based on the time it occurred. If yes, then we'll have YTD, otherwise the column will remain empty. All right. To achieve this in Excel, we'll use an if function. The if function will determine whether the current year is the same as the year value in our date column. In other words, we check whether D2 equals the year in C2. If yes, we will have YTD. Otherwise, we leave the cell empty. Let's paste the function downwards and see what we've obtained. If we scroll down, we will see that the if function worked well. It shows YTD for 2020 values. But then, when the year switches to 2019, the formula no longer shows YTD as expected. Therefore, the cells from here on are empty. Very good. Continuing with the second column, here, we'd like to see if a row's date occurred in the last 12 months. This formula is a bit trickier, but bear with me. We'll go through it step by step. To obtain a working formula, we need to ensure that the date value occurred in the last 12 months with respect to the current reference date in our dashboard. Let's see how we can translate this into Excel lingo. Once again, we'll use the if statement. This time around, though, we require 2 conditions to hold true. In a situation where we need to check whether 2 conditions are true simultaneously, the AND function will help us too. Okay, it's time to start building the function. First, we must check if the date in C2 is greater than or equal to the current reference date in our dashboard, -12. We are looking whether it occurred in the last 12 months, right? So given that a year has 12 months, we need to see if the date occurred somewhere in the span between the current moment and 12 months ago. However, here it's better to go back 13 months instead of 12. The reason is that our current month might have not ended yet, and hence there might not be sufficient data here. A convenient way to perform this check in Excel is with the end of month function. Let's check if the value in C2 is greater or equal to the current reference value in our dashboard, minus 13. Remember to add a 1 at the end, otherwise the check will send us to December 2018. And now the second condition. Well, we're checking for values that occurred in the last 12 months, so our value needs to be smaller than the reference date in the dashboard. Again, we require the end-of-month formula and check whether C2 is smaller than the end-of-month value in our dashboard, minus 1. All right, now if both conditions hold true, the date in a particular row can be classified as LTM. Hence, we will have LTM. Otherwise, the formula will produce an empty result. Phew! Let's fill the remainder of the column and see what happened. Excellent. The months after March of 2020 are left empty. So are the ones before April 2019 because they cannot be classified in LTM if our reference is April of 2020. Great work, everyone! This completes all the steps to obtain the source data, which is also the basis for building the report. The next part of our exercise requires some extensive work with pivot tables and the Get Pivot Data function. Great features in Excel. See you in our next video. Hi and welcome back. In this lecture, we will create a pivot table, which will serve as the backbone of the dashboard we want to build. The pivot table will use the source data we worked with so far. Besides, it will allow us to extract certain parts of the data through a Get Pivot Data function. First, though, let's spend a moment discussing pivot tables, in case you're coming across them for the first time. Pivot tables are Excel's dynamic and interactive tables. This is a crucial element for a dashboard, as in it you slice or filter the data. We'll use a pivot table to add a slicer as well, but first, let's discuss the pros and cons of using pivot tables. We already mentioned they're dynamic and interactive. They are also quite efficient. For starters, with a pivot table, we could summarize thousands of rows of data in seconds. And, as we'll see in a moment, creating a pivot table is very user-friendly, even if you're a beginner. All you need to do is drag and drop the field you are interested in, so no need to write complicated nested functions. Not only that, but pivot tables are great at handling large data files, as working with functions makes file sizes heavy after a while. The drawback of working with pivot tables is that they are high level, and we won't be able to see the actual equations required to calculate the entries. Moreover, pivot tables do not update automatically, which could become quite inconvenient if you're changing your source data frequently. All right, with all this in mind, we're ready to create the pivot table necessary for this exercise. Let's select all data in our sheet with Ctrl and A. Next, from the Insert menu, we select the pivot table. In this menu, we could manually select the source for our pivot to be our Excel file, or we could even choose an external source. And we're able to specify a location for the pivot table we're creating. Let's stick with a new worksheet and click OK. First, we rename the new sheet to Pivot Financials. Next, we must specify the rows we will need. Of course, we'll have month and year, as well as size. These will form the rows in our pivot table. Next, onto columns. I'll drag the client type field here. Great! The remaining entries will be the sum values of volume, gross sales, discounts, net sales, cost of goods sold, distribution, and lastly, warehousing. Perfect. And that's all we need in our pivot table. In the following lectures, we'll use the information from the pivot table to obtain the values for our own dashboard charts. Thanks for watching. Hello again. In the next few lectures, we'll focus on obtaining the information required for our dashboard. We'll form a few tables, which will serve as the basis for the charts in our report. Also, we'll calculate a few key values that we'll then transform into KPIs. Sounds good? Let's begin then. We'll start by adding a link to the current and reference period in our dashboard. These will be instrumental for calculating values later on. So for convenience, we add them to this sheet as well. Remember, we already have them in the dashboard sheet. From there, we first take the value for the current period, which is in cell B5. All right, the next step is to include the reference period. It's under the reference period, as you might expect. Once again, we'll use the if statement. Great. These values will help us with our next task, which, in case you're wondering, is to create a table with dates. This is one of the trickiest parts of the entire building a dashboard exercise. If you remember, while planning, we intended for the user to be able to change between two time formats, year-to-date and last 12 months. This means that our data will have to be flexible and change when we change the period, reflecting the different values. To ensure this happens smoothly, we must add date references here, which will point Excel to the correct values. In any case, I'll guide you through the process of creating each row in the table, so let's begin. First, let's write down the numbers from 1 to 12 to represent the 12 months of a calendar year. Keep in mind here that they don't necessarily represent the months from January to December. These are just 12 calendar months, which we'll need later on. They'll serve as a basis when we apply certain mechanics to obtain the actual dates we need to be displayed based on the period selected by the user. Speaking of which, the first calculation is related to the LTM months. Here, we'll have the last 12 months depending on the current period. So if we're currently in June 2020, then we need June of 2019, July of 19, and so on. The last month will be May of 2020 to complete the last 12 months. Lucky for us, we can easily compute the first value with some help from the end-of-month function. End of month requires us to enter the current period, which is June 2020. As a second argument, we subtract 12 months. The result is June 19, precisely as we wanted. Now we can fill in the remaining cells using the end-of-month function. Only this time around, we'll take the already calculated June 19 cell and add 1 month. The result is July 2019. There are other options to compute the values. This is just one I find easiest. Great. Let's copy the cell and paste it in the remaining empty cells in the row. Excel automatically adjusts the formula and everything is calculated as we intended to. Cool! This means we can proceed with the next row, which will contain year-to-date values. To calculate them, we'll use the if function. We'll check if the month in our current period is larger than the month in the table. In our case, that's the value in C8. Okay, if the condition holds, we need the first month in the same year as our current period. To compute it, the end-of-month function proves handy again. From the current period, which is in cell B4, we subtract the number of months in B4. The result is December 19, which is 1 month further than we'd like. Again, this is because our current month is not completely over yet. So what we can do is add the one missing month from cell C8. Okay, this is when the expression is true. Otherwise, we leave the cell empty and let's see. Exactly as we wanted. The value is January 2020. Let's return to the formula and fix B4. We can do that by adding a $sign for both column and row values. By the way, the shortcut to do this is F4. By fixing the cell reference, we ensure that when we copy the formula, the reference to cell B4 won't shift, but will remain in place. Great! Let's copy the cell and paste it in the remaining empty cells in the row. Amazing! The correct values have appeared. The year-to-date ends with May of 2020, as it should. Before we move on, let's examine the way the formulas have changed after we've copied them. We observe that as we've fixed the cell B4 with $signs, it has remained the same throughout each cell. On the other hand, the reference to the cell C8, the one we didn't fix, was updated to shift to the right with each cell. Please make sure you remember this, as it is one of the most important ways to keep your formulas in check. Besides, we'll be relying on fixing cells by columns or rows in the next lecture when we create the other tables. Next up, we'll add date fields to our table. Hello! In this lecture, we'll include a few additional time-related values. The first one will be the month. Then we'll have the year. Lastly, we'll add a selected dates row to obtain the months we're observing in our dashboard. Let's begin with the month. Here, the reference period is key. To obtain the month, we check if our reference period, or cell B6, is LTM. If yes, then we extract the month from cell C9. We can achieve this by taking the text for the month, which is specified with double M's. Alright, in case the if condition isn't true, we take the month value from the cell C10. Excellent! Before we copy the formula, let's fix the appropriate cell rows and columns. The cell B6 remains fixed, as we're always looking for the reference period in our check. Also, we need to fix cell 9's row references, as the columns will shift one to the right with each next month. And the same goes for cell C10. Super! Let's copy and paste. Great work, everyone! Now the year field. This calculation is very similar to the last one, so much so that I'll just copy the value from the cell for month and adjust it to reflect the year instead. In the brackets here, we require Y for year, which takes 4 spaces in total. So 4 Ys are needed. Cool. Let's also fill the remaining columns in the row. And last but not least, we must include a row with selected dates. This will show the dates we're looking at in our dashboard, depending on the reference period that's been selected by the user of the file. In other words, we'll show either last 12 months or year to date. For this calculation, we'll rely on the if-error function in Excel. The if-error function can return a custom result if there is an error and a standard result if there isn't one. This is yet another Excel function we'll be using often for the remainder of this section, so make sure you're paying attention. Alright, what we'll check for here is whether the month and year cells are empty or not. This is important for the year-to-date scenario where we'll definitely have some empty spaces. So to obtain our current date, we'll rely on the end-of-month function you're already familiar with. Then, for the year, we take the value in C12. For the month, we need the cell C11, and we add 1 for the day, The day is irrelevant in this case, as you know we're only looking at monthly data. Okay, if the result here is 0, or in other words, we have an empty cell, we leave the cell empty without raising an error. Excellent! We don't need to fix the cell and can copy and paste the formula to fill the remaining columns in the selected dates row. Marvelous! We've done a lot of hard work for one small table, but these calculations will aid us tremendously when we start calculating the main tables for the dashboard. Thanks for watching. Hello again. It's time to prepare the values for our bar and line chart, showing net sales and gross profit development. This type of chart is very useful, as it allows us to understand and track a company's growth. Net sales is the primary figure reviewed by financial analysts when analyzing a company's performance. It's the number of sales once discounts have been taken into account. As such, it's the actual number that goes into a company's bank account and is what we'll represent using a bar chart. Now let us consider the cost of goods sold, or in other words, the figure showing how much it costs to manufacture certain items. If we subtract COGS from net sales, we'll obtain gross profit, the margin that the company is able to make by selling its product. This figure, represented as a percentage, will give us the line component of the combo chart we're building here. Cool! So we need to obtain these values in our table. Even though we're considering net sales and gross profits only, we'll include a few extra rows in the table, representing other important values such as distribution and warehousing costs. Actually, let's first list the columns in our table, and then we'll fill in the blanks. To do so, we'll enlist the help of our pivot table. Let's see, we have volume, gross sales, discounts, percent of discounts, net sales, cost of goods sold, gross profit margins, distribution, percent of distribution, and lastly, warehousing. So far, so good. Now, how can we obtain these values? I imagine that you already know we'll be using data from our pivot table. What you might not be familiar with is the function we'll be using for the task. It's called getPivotData, and it basically lets us grab the value and references from a pivot table cell. Let's try it out. First, we require the getPivotData function. Then we can switch to the Pivot Financial sheet, where we have sum of volume in the second column. Let's select a value here. It can be any value, as we'll adjust the references later. So let's copy the result and head back to our table sheet. Then we paste the value in the desired cell and press Enter. Marvelous! Sometimes copying values from different sheets can be a bit tricky, so be mindful of that. Okay, great. Now comes the most important part. We'll need to replace some pivot references with the ones in our table sheet. This is necessary for the charts to function properly, and it will also help us fill in the remainder of the table much more easily. Let's go ahead and do that. First, instead of sum of volume, we'll have sum of, and then add a link to our volume cell, B16. Pay close attention here. The empty space after the of must absolutely be present. Otherwise, you'll receive an error. Okay, what else? Well, instead of the hard figure we see for month, we'd like to have our current month, right? So let's add the C11 reference here. Of course, the same goes for the year and the C12 cell. Good job! Moving on, we don't need to specify a type of client, as right now we're interested in all clients. Lastly, to ensure everything runs smoothly, once again, we'll include the if-error function to make sure we don't have any errors if the cell is empty. This could happen, for example, if we're in the year-to-date scenario and we're not looking at a period that has 12 months. Great. Now the result has changed, as we're no longer looking at a specific client type. But all is well, and after fixing the appropriate columns and rows, we're ready to copy this cell and paste it not only to the left, but for the gross sales and discounts rows as well. Let's see what we obtained. Cool! The next row is the discount in percentages. We can calculate it by dividing the discounts by the gross sales. Let's add the if-error function here as well. Okay, we can fill the rest of the cells in the percentage discounts row with copy and paste. Now let's format the numbers to show percentages. Go to the Home tab and click on the Percentage option. Here it's conventional to have two numbers after the decimal point, so let's do that. Cool. Lastly, here we could directly calculate one of the dashboard's KPIs. It's the total discount. As such, it is the average of all the separate discount values. So we need the average of cells C19 through N19. Good. Moving on. Next up, we'll calculate net sales. What we can do is copy the cells in the volume row and then paste for net sales. As we've done our work well in terms of referencing the table, Excel automatically updates the correct values. Good job! We could directly fill in the blanks for cost of goods sold. No fuss, no muss. All right, we're making great progress already. In the next lecture, we'll continue by calculating gross profit and distribution costs. Thanks for watching. Time to calculate Drinko's gross profit. Well, the gross profit is given by the difference between net sales and the costs of goods sold, right? So in our table, this would be the sum of net sales and COGS, given that COGS has a negative sign already. The next value we require is the gross profit margin. Gross profit margin is calculated rather easily. It is given by gross profit divided by net sales. All we have to do is divide C22 by C20. Don't forget to add the if-error function in front and also format the numbers as percentages. Okay, only 3 more rows to go. Distribution costs are fairly easy to obtain. I'll copy the formula for the first row. And as far as the distribution in percentages goes, it's nothing groundbreaking. It is the distribution cost over the net sales, which is in cell C20. Great! This is the place to calculate the second KPI for our report, namely the overall distribution cost. As you might have guessed, it is the average among the individual distributions. Let's turn these numbers into percentages as well. And we've come to the very last row, which is the warehousing cost. Also an important metric to have for your analysis, even though we won't be including it in the actual dashboard. We're selling physical products, so warehousing costs are an important factor to keep in mind. As far as calculating it, you know how this goes already, by copying the first row. And that's it. We've successfully created our net sales and GP development tables. What remains is the volume by size and by client type tables. The former is the topic of our next lecture. Of course, you'll get a chance to create the latter yourself as homework. Don't be square. See you there. Welcome back. In this lecture, we'll create the volume by size table. The table will serve as the basis for our second dashboard chart. This is a visualization that would allow us to track the firm's sales volume based on the size of the type of packaging that was used. This way, we'll be able to see which product size performs best overall or by brand. Before we can create the chart, though, we must prepare our data table. Let's begin by filling in the rows with separate values. Here, you could directly copy them from the raw data sheet and remove the duplicates, as we did when creating the drop-down list with our dates. However, I prefer to have the rows organized in increasing order, which wouldn't necessarily happen if we stick to the other approach. All right. Now to fill in the first cell, we must extract data from the pivot table once more. Again, we'll use the getPivotData function. Let's switch to the Pivot Financial sheet, then go to the Sum of Volume column and select an entry here. Again, let's copy the information and return to the table sheet. We then paste the values in the first cell and press Enter. Cool. The first part's over. Now we move on to fixing cell references. And hopefully, as in our previous lecture, this hard work here really pays off. Okay, we start with the sum of reference, which we alter to point to the volume cell B29. We go ahead and fix the cell reference, as it won't change across the table. Next, we change the month and year references to our date values and fix their row references. Last but not least, here we need to add a cell reference for size too. In this case, it will be cell B30, and we have to fix its column reference. Great! Let's add the usual if error check and see if the formula works well. Excellent! Now, believe it or not, we're ready to populate the remainder of this table. As we saw earlier, the hard work we do while changing references and making our formula flexible helps us save time later on. There's only one additional row to fill in, which is the total. So, let's add one more column to our table, which represents the total amount. In this column, we simply sum the volumes for each month. We need to do this for each row in our table. When we create the volume by size chart, we'll rely on the total category instead of using monthly data. There are two main reasons why. First of all, we simply have too many values. To display the entire table, we'd end up with 9 times 12 values, which is way too many for a single chart. The second and more important point is that we simply do not need the monthly granularity here. It makes more sense to examine the performance of each bottle size overall and compare it with other sizes. Having monthly data would mean that we can compare the sales of 250 milliliter bottles with the sales of 2-liter bottles. But for the month of, say, January, having such a metric doesn't make much sense. But comparing the total sales for each bottle size and by brand is a key aspect in the business model. Okay, we are ready to wrap it up here. There's only one remaining table to fill before creating the actual dashboard, and it's also your homework task. I'm sure you'll be able to solve this as an exercise on your own. This is a great way to reinforce what you have learned in the last few lessons. Take care, and thanks for watching. Hi again! We're finally ready to start creating our charts. Exciting stuff! We came a long way and worked hard to get to this point. We'll be able to use the information from the tables we created in our previous lessons to build beautiful visualizations that can be combined in a good-looking and informative Excel dashboard. Hopefully you got a chance to complete the homework task in which you were asked to create the volume by client type table. If you didn't, you can find the completed Excel sheet in the downloadable resources. In any case, we've obtained all the necessary data to finally start shaping our dashboard. Hope you're as excited as I am. Okay, recall that our first dashboard graphic was a combination of a bar and line chart. It will track monthly net sales as well as gross profit margins. Both values give us an idea of how a firm's business is growing or is developing. The trend of revenues shows whether a business is expanding and at what pace, while gross profit margin gives us an idea regarding profitability. We'll use different scales for the two parameters. So a combination chart with a dual axis would be perfect for representing revenues and gross profit margins together. Good. Let's begin by selecting the actual data. From our table, we require the net sales, the gross profit margin, and finally, the reference dates column to obtain the dates. Next, we'll start creating the actual chart. From the Insert menu, we go to Recommended Charts. When you come here, if Excel suggests this clustered column option with a line chart, you can go ahead and select it. Otherwise, you'll need to go to All Charts and select the last option, which is Combo. For gross profit, you must then check the secondary axis option. Let's see. Well, it worked! Great job, everyone! Let's take this chart and move it to our dashboard sheet, where we'll do some additional formatting. By this point, you're well familiar with chart styling, so we won't delve into much detail. We'll remove the fill and border of the chart and adjust the font and its font size. Arial of size 8 should do the trick. Next, we'll format the y-axis. More precisely, from the Format Axis menu, we'll format the number type. We'd prefer the axis ticks to be actual numbers, but we don't need the zeros after the decimal point, so let's opt for 0. Good. What else? We can increase the size of the chart by extending it to the right. This way, we'll have a better overview of the individual months. Now it's time to format the line chart a little bit by selecting the Marker menu from the Format Data series. Under Marker Options, we opt for Built-in with a size of 6. Also for type, let's go with the diamond. Cool. Now on to the colors. Once again, we'll rely on the 365 Data Science color scheme, but you're welcome to explore your own color palettes, of course. Promise we won't take it personally. Okay, let's have a 365 Data Science blue for the bars, As for the line chart, we can have a yellow or orange color. We could actually include both. orange for the line itself, and then yellow for the marker. Let's see, there is an orange color which is nice with the hex code EE4F23. As for the marker, the yellow I'm thinking of has the code F99F10. Great. Let's also include Y-axis titles. From the Charts Design menu, we can add a primary and a secondary vertical axis. The primary Y-axis shows the net sales, whereas the second one is for the gross profit margins. What's left to do is add a meaningful title to our chart. How does net sales and GP development sound? I personally like it very much. If only we were able to increase its font size a little bit so it stands out more. For instance, 11 would be a good option. Let's bold it, shall we? And what do you know? Our first chart is complete. In our next lecture, we'll create the volume by size and by client type charts. But first, let's get a little preview of what we can already achieve with our dashboard. If we go to our current period and select a different date, our chart automatically adjusts to reflect the new period. If you go to the radio buttons in the reference period, you'll also see that they are functional. Cool, right? All right, you're free to explore and play around with the options a bit more, and I'll see you in the next lecture. Take care! In this lecture, we'll create the second visual element for our dashboard. It is a clustered bar chart, showing the volume of purchases by the size of the drinks containers. So far in the course, we've not explored a clustered bar chart in great detail. You can look at it as an inverted columns chart, and in essence, this is precisely what it is. I find that with this chart, it's much easier to track the difference among the size of different bars compared to the regular bar chart. In any case, creating it won't be very technical. Instead, we'll concentrate on chart styling. First, though, we require some data for our chart. So from our table of volume by size, let's go ahead and select the first and last columns. As we've discussed, for this chart, we're interested in tracking the volume of purchases as a whole, not on a granular level. Let's insert a recommended chart. And already the second option here is a clustered bar. In fairness, here you could choose a different visualization, which would display the same information, but this is my preferred option. Okay, let's head to the dashboard sheet and continue with chart formatting. We position it under the first chart on the left. First, we should remove the border and fill of our chart. Next, we adjust the font and font size the same way as we did for our combination chart. The next step is to increase the width of the bars slightly. This is achieved by reducing the gap width from the Format Data Series menu. Around 50% would be sufficient. Now let's format the x-axis and turn the x-ticks into numbers, just like we did for the y-axis of our combination chart. So far, so good. Now on to color, my favorite part. We'll choose a custom color for each bar. We'll stick with the color theme we've used so far. However, as we have 9 bars in total, we'll require a bit more color variation. In essence, we'll divide our data into blue and orange colors. The oranges will be 250 and 500 milliliters, as well as 2 liters. We begin with the bar for 2.25 liters. Let's double-click it and make sure it's the only one selected. Otherwise, the color for all bars on the chart will change. Again, we'll rely on choosing custom colors and go to the More Fill Colors option. For the first bar in our chart, a light blue color with the hex code CFB7EB is in order. Next, for the 2 liters, we can switch things up and select a custom yellow color. How about we try FBC570? Excellent. For 1.7, a data science blue would fit nicely. Let's go with 70B8C2. For the 1.5 liters category, we've reserved the darkest blue in the dashboard. The hex code is 005559. Okay, for the next category, we have 11889A. The one that follows will be 0D7984. Which leaves us with the last remaining blue bar on this chart. And its code is 66999B. Cool! For the remaining 2 categories, we'll have orange colors starting with 500 milliliters. Let's double-click it and change the fill color. Here we could have a bright orange with F99F10. Confirm with OK. And now we've come to the last category and its color. For the 250 milliliter, we'd like to select a peach color, and the code is FDD99F. Now, doesn't this look nice? Only one item left on the agenda. You guessed it, it's adding the title. Volume by size is the name we'll go for. Let's increase the font size a bit more and have it in bold. And there you have it. 2 charts down, 1 to go. See you in the next lecture. Welcome back. It's time for the last of the trio of charts in our dashboard, and it's a welcome return for the clustered bar. First, we head over to the Volume by Client Type table and see what it now contains. For this table, we're tracking the size of purchases according to client type. We have 4 categories in total. Big box, which are physically large retailers, commonly part of a chain of stores. Discounters, which usually sell products at lower than the retail prices. Grocery stores and supermarkets. This data will help us track where our products have been placed most successfully. Also, looking at these numbers, we're able to spot if a product is failing in one of these areas. Thus, we could devise a strategy to target a type of client to increase sales there. Now onto the chart itself. From our Volume by Client Type table, we'll select the first and last columns. As with our previous chart, here we're interested in the aggregated data, showing the purchase volumes for the client types. We can insert the actual chart, and we select a clustered bar chart as discussed. Cool. The next part is to style it appropriately, so it fits with the remaining parts of our dashboard. Let's position it next to our volume by size chart. All right. We remove the fill and border of the chart and alter the font to Arial with a size of 8. Again, we increase the size of the bar charts by reducing the gap between them. Good. The next step is also familiar as it involves formatting the x-axis. From the Format Axis menu, we alter the X ticks into numbers by selecting Number from the drop-down menu. Okay, this means we're ready to pick the colors. And again, each bar will receive an individual color. Let me see. Let's double-click on Big Box and give it the 365 Data Science Blue treatment. The good news here is that we've already created custom colors for our previous charts, so we can just borrow them here as well. From the Recent Colors row, we can select an orange color for discounters, and then a peachy color for grocery. The last color we pick is for the supermarkets, and let's make it a blue color again. Great! What comes after the color component is adding in the new title. It reads Volume by Type of Client. Of course, we'd like to increase the font size somewhat and bold it. Marvelous! Our charts are now complete. Here would be a good place to check if our date references are linked to our new charts as well. Let's switch to last 12 months and set the current period to April of 2020. Excellent! Everything works as intended. We'll conclude this lesson now, and in the next lecture, we'll add some non-charts components to our dashboard. See you there, and thanks for watching. Hi again. We've already completed the 3 charts that will form our report. Technically, you could stop here and have a perfectly well-functioning dashboard. But we'll go ahead and add a couple of additional elements to enhance the functionality of our dashboard. This in turn will help us answer more strategic questions concerning our business. First, we'll add a few KPIs. The key performance indicators we'll track with our dashboard are related to the average discount and the average distribution cost. Our dashboard is centered around sales and orders, so these 2 metrics certainly make sense. When performing your own analysis, you're welcome to include any KPI you deem important for your company. And the good news is that we've already computed the KPI values. Yes, if we switch to our table sheet, we'll spot that we've computed the average discounts as well as distribution costs. The fact that at the beginning we spent some time to have a clear idea of what we're trying to build helped us prepare these values while solving the exercise. Now, all I need to do is copy the value for, say, average discount and place it in here. Let's also add a description, average discount, to make it clear to everyone what this number represents. Next, we copy the average distribution cost value and place it in our report, under the Volume by Type of Client chart. Let's add a descriptive name here as well, like average distribution cost. Excellent! We'll have a separate lecture on styling, where we'll format the different dashboard elements, including the KPIs. For now, let's go ahead and add the next element. Finally, it's time to include some slicers. You could say a dashboard is never truly complete without slicers, right? In our case, we'll add a slicer for the brand. To add a slicer in Excel, we must first go to our Pivot Financial sheet. Then, from the Insert menu and then in Filters, we're able to select a slicer. And with this drop-down menu, you're able to select a slicer for any column in your data just by selecting it. Our dashboard requires only one slicer, though, Brand. Of course, you could choose more or different slicers as well. Nevertheless, being able to slice and dice the data in terms of brand and to see how different brands are evolving is invaluable for a manager. Let's move the slicer with Ctrl and X and paste it onto our dashboard with Ctrl and V. While we're at it, we could quickly check if it's working. Yes, our data has been filtered. Amazing work, everyone! We can now filter our data by each brand, and each element in our dashboard changes dynamically along. This was a lot of hard work, but it's about to pay off. In the next lecture, we'll continue with formatting. I'll see you there. Hello, and welcome to the lecture on styling the appearance of our dashboard. This process is very important as it shows attention to detail and helps us represent the information on our dashboard clearly and professionally. So we start with the overall style of the sheet. Now we'd like for the information on the dashboard to stand out a bit more. To achieve that effect, we could introduce a gray background to our sheet wherever there is empty space. Let's see. We select all empty cells with Ctrl and A and add a light gray color. Next, we select the cell where our graphics and KPIs are and change the color to white. Excellent! Now let's format the drop-down menu so it fits with our 365 color scheme. Just select the cell and include a background color. Great! Now let's change the text to white so it stands out more. To that effect, we could also have it in bold. Okay, what else? Well, we could increase the KPI values so they stand out more, right? Here we could go ahead and merge several cells. Let's try it out with the average discount cell first and merge it with several adjoining cells like that. Now we can increase the font size to 14 and have it in bold. Let's also add an underline. Then we must do the same for the remaining KPI attributes, like the distribution cost and the actual percentage values. As mentioned, you could also add your own KPIs to enhance your analysis. Alright, great. Let's wrap it up here. In the next lecture, we'll customize the appearance of the slicer. See you there! We're ready to proceed with the next step, changing the appearance of the slicer. First, let's position it at the top of our dashboard so it's easily accessible. Here we could add a few additional rows to our Excel sheet to increase the space for the slicer. Okay, now for the slicer, we'd like to forego the scroll-down menu. Instead, having all brands visible at all times would be much more convenient. See how we can achieve this? Let's first expand the slicer to the right like that. Next, we navigate to the Slicer menu. Here we have many options to format the appearance of slicers. Let's go to Columns and increase their number. Great! 8 should do it. As we have 16 brands total, and we'll separate them into 2 rows. Now this looks better, but we could still format the slicer to fit in with the remaining part of the dashboard. In other words, it's time for the slicer to get the 365 treatment. Okay, let's go to Slicer Styles and expand the menu. Here we have the option to choose one of the default Excel layouts, but we're also able to create our design. If we select the new slicer style, we see that we could customize the appearance of various slicer aspects. For instance, how the slicer looks if we've selected an item, how it changes when we hover over it, and so on. What we'll do for our dashboard is to first format the appearance of the whole slicer. Let's go to Border and select the 365 blue. We also select the continuous line here. Next up is the header look. This is the top line here with the brand text. For its style, let's go ahead and select a bold font. For the border, again we'd like it to be our blue color with a continuous line. Good. We follow up with the selected item with data, which is the third option. Here, let's select an Arial font. It's regular in terms of size, but let's alter the color to white. Afterward, we switch to the Fill menu and choose a custom color. The code is 108AA9 for the 365 blue, and we confirm with OK. Great. For a selected item with no data, we'll include a gray background. Let's go to Format and select this gray here. OK. Now the same procedure for selected item with data would make our slicer style complete. Excellent! Great job, everyone. As a last detail, we could align the separate elements of our dashboard. This will make sure we're absolutely bringing our A game. Let's go to the Shape Format menu and align the charts to the left. This could be somewhat fiddly, but that's why Excel helps us align different elements in different ways, to make sure we get the best results. And we're just about done. Hopefully you can see the drastic change that styling had on our report, and it's guaranteed to make an impression on your audience as well. And this concludes our styling chapter on Excel dashboards. Until next time! Welcome to the interpretation lecture for our Excel dashboard. We did a lot of work in Excel. We also formatted quite a bit. Before that, we planned extensively. I'd say it's time to take a look at what we did and possibly interpret the results we see. Shall we? This is truly where all the hard work from the previous lectures pays off. Our dashboard is now complete and functional. You'll agree that it wasn't the easiest of tasks, but we didn't shy away from the work and we're ready to reap the rewards. With this report, you could track the monthly development of your company, or better yet, you'll get the chance to impress the CEO of the company you work for. What this dashboard provides is a dynamic way to monitor the development of your business by month, quarter, or year. We're able to track our net sales and gross profit margins and thereby determine if our company's growing sustainably. In addition, the brand slicer would allow us to observe this at the brand level, where we'll see how different brands are performing. Answer to key questions such as, who are the top performers? Are there brands that are losing us money? Are there brands that aren't growing fast enough? And so on. Even more than that, our report could help us improve our numbers in the months to come, or help us come up with a new strategy at a company or brand level. Say we wanted to target grocery stores, which at the moment is our least preferred client type. We could filter our data to individual brands and observe which one generates the most sales in the grocery category. This would be the Dundee Max brand with a volume size of nearly 1,700,000. If you wish, you could take it one step further and include a client type slicer, which would allow you to focus on one particular client type and track its development. It's up to you. Alternatively, you could take a brand approach and analyze the performance of a particular brand. Say we were interested in our Evan Vitamin brand. If we selected it from the brand slicer, we could track the development of only this brand. It appears to be one of the least profitable across all brands. Now, if we pay attention to the combo chart of net sales and gross profit, we'll observe that the Evan sales are in the 2000s. Compare these with a larger brand, for instance, Dundee one. Its sales are in the 500,000s. That's a difference of 2,500 in the order of magnitude. So without the option for looking at individual brands, smaller brands such as Evan Vitamin are completely lost, as they do not contribute enough to the entire sales to make a profit. Nonetheless, it could be that they're actually more profitable than larger brands. When discussing brands and brand slicer, there is one additional functionality worth mentioning. Apart from a single brand, you could select multiple brands simultaneously with the slicer. Just hold the Control key and click on any brands you'd like to examine. This way you can track the development of a few key brands or target a group of brands specifically. Okay, great. As you can probably see, we have numerous possibilities here, and I bet you're already trying out different options as well. We're just about ready to wrap it up. Before we do, let's revisit the main takeaways for creating a dashboard. First and foremost, make sure you have a clear and well thought through concept of what your dashboard will represent from the start. Think about the main goals for your business and what you'll need to include in your report to help you achieve them. Invest time in both the mechanics and the styling of the dashboard. And as a last step, refine your dashboard by using it. Investigate how well it answers the questions you set at the beginning of this task, and then use the opportunity to refine your goals even further and make them more focused. Remember that each business is unique and requires a well-tailored and specific strategy. Moreover, your strategy and goals might need to evolve and change over time, which means the same thing for your dashboard, by the way. So you can refine your KPIs or your dashboard charts to make them even more focused. This way you can keep improving your strategy. Finally, don't be afraid to explore ideas and concepts beyond what we've shown here. I bet you'll come up with some amazing stuff. Good luck, and until next time. Hello everyone! In this section, we'll learn how to create dashboards in Tableau. Luckily, Tableau is built for this purpose, and dashboard creation is very intuitive and as easy as possible. For our report, we'll be analyzing data from a company called Drinko, which operates in the FMCG industry and sells different brands of drinks. At the top part of the report, we'll have a combination chart displaying monthly net sales and gross profit margins. Then, below this chart, we'll include two inverted column charts. The first one will show the volume of purchases based on container size, and the second will also display volume, but this time by client type. But that's not all. At the bottom of our dashboard, we'll add two KPI values: average discount, the discount clients receive when making a purchase, and distribution cost, the relative cost of delivering the item to the client. Metrics like distribution and warehousing expenses are important when considering physical products, as the products need to be stored and shipped. But depending on the type of business you're examining, tracking other metrics might be more valuable. All right, now I'm very excited about the next part we'll include in our dashboard. It's the feature that sets a dashboard apart from most reports: adding interactive filters. A dashboard is dynamic. As such, it enables us to filter the data and examine only parts of it based on specific criteria we've selected. And we'll get a chance to explore filters by creating two of our own. First, we'll include a time filter allowing us to alter our data view by period. In this way, we'll be able to look at a specific month, a quarter, or any other type of time frame. The feature is extremely useful for tracking the progress a company has made in the last quarter, a few quarters in a row, or years. This helps us stay on top of our game as we can dynamically monitor the company's performance in terms of sales and growth and take corrective actions if necessary. And finally, we'll also add a brand filter. With it, we can examine data for a particular brand or a group of brands within the Drinko company. For a large company such as Drinko, this adds valuable insight into the performance of individual brands. Sounds exciting, doesn't it? In the next lecture, we'll start working with the actual data for the report. See you there, and thanks for watching. Welcome back. We're ready to load the data set for the task at hand. Let's connect to our data source, which is in the Dashboard Data CSV file. To download it, check the resources available with the lecture. All right, we can now examine the structure of our data, and what we observe is that this is time series data. Okay, then we've got some information about Drinko's clients, as well as a categorization by client type. And in addition to that, we have financials. First, we have gross sales that show a firm's revenues pre-discounts. If we then consider discounts that had been given to clients, we will arrive at net sales. What else? Well, on the right side of the table, there are 3 additional cost items: cost of goods sold, distribution, and warehousing expenses. Quite intuitively, cost of goods sold shows how much was spent to make the product. Distribution and warehousing are 2 items that are often grouped. Distribution is the transport expenditure that has to be sustained to deliver a product to a client. Warehousing indicates the cost of keeping the item in the company's storage facilities until the item is delivered to clients. All right, with all that cleared up, we can start working on the actual report. Let's turn our attention to the Tableau Sheet tab at the bottom. From here, we're able to create new sheets, dashboards, as well as stories. For our report, we'll require several sheets as well as a dashboard, of course. The reason we need additional sheets is that we'll be creating each element of the dashboard, such as the charts and KPIs, separately in their respective sheets. Then, we'll link all of the elements together in a dashboard. And as the last step, we'll include filters and connect them to all elements of our board. Cool! Let's go ahead and create a dashboard called Drinko Report. Next up are the individual sheets that will form our report. We begin with net sales and gross profit margin. The second chart will display volume by size of purchase. In case you're wondering, this is what an inverted bar chart is called in Tableau. Pretty much every software has a different name for it, so it can get confusing. The third chart will depict the volume by client type and will also feature horizontal bars. Then, let's create 2 sheets for the dashboard KPIs. The first will show the average discount. The second is for the average distribution cost. Excellent! Now we're ready to create the actual charts. And we'll start with the combination chart for net sales and GP percentage. See you in the next lecture. Hi! In this lecture, we'll be creating our first dashboard chart. It will be a combination chart displaying the monthly net sales and gross profit margins. On the one hand, the chart will feature a bar chart with the monthly net sales. This will show whether our business is expanding and at what pace. Then, a separate line chart will display the monthly gross profit margins. This in turn will give us an idea about profitability. Both charts will share the same month and year on the x-axis. But they'll have separate y-axes, as the 2 metrics we're displaying are of different scales. Net scales are shown in currency, whereas the gross profit will be displayed in the form of percentages. Okay, great. With that cleared up, we can begin. First, we'll create a bar chart showing sales. Let's double-click on the year and month and put them under columns. They'll form our x-axis. Then, from the Measures panel, let's drag net sales to rows. Excellent. Now let's convert the month and year fields to discrete measures. To do that, we need to right-click and select Discrete instead of Continuous from the drop-down menu. Cool. So that's our bar chart. What about our line chart then? Well, to compute it, first we need an additional field. Let's go to Analysis and create a calculated field. Great. This is where we'll calculate the margins. The gross profit margin is calculated as net sales minus the cost of goods sold over net sales. Basically, the amount we actually make when selling an item, gross profit, divided by net sales. All right, here it's really important to take into account the fact that we need to sum. Otherwise, we won't be dividing the total figures for each month. The reason behind this is that our monthly data is split into multiple rows. For each month, there are different rows, showing separate deliveries to multiple clients. But for the gross profit margins, we require the total amount of sales each month. Hence, we must sum up our data. So let's have the sum of net sales plus the cost of goods sold. We sum up with a plus sign, as the cost of goods sold variable is represented with negative values in our data. Lastly, we divide by the sum of net sales. And voila! Now we can add this new variable under rows and see what we've obtained. It's a second bar chart. To convert it into a line chart, let's go to Marks. Make sure we've selected the graph showing gross profits. Okay, now let's choose a line chart from the drop-down menu. Excellent. Finally, instead of having two separate charts, we ought to have one graph with a dual y-axis. To do that, right-click on the y-axis of our line chart and select a dual axis. And there it is. We were able to obtain the desired chart. Now let's style it up a bit, shall we? First, we know that the secondary y-axis is supposed to show percentages. To change the format to percentages, let's right-click on it and select Format. Instead of numbers, we want to see the percentages. The number of decimal points is a judgment call, so we'll stick with the default option of 2. Cool. Just like we wanted, the line chart shows monthly gross profit margins. However, when displaying line charts with time series data, we can depict a different level of granularity. On our chart, we're observing monthly data, but a viewer might think it's weekly or daily data. To avoid ambiguity, we should add line chart markers. From Color, let's select the second Markers option. The markers make sure that only the points that we have data for are highlighted. Let's also increase the chart size slightly through Size. That should do. And how about giving our chart a proper title? Something like Net Sales and Gross Profit Margins. Sounds good, doesn't it? Now that we've got our title, we can go ahead and bold it so it stands out a bit more. Great work, everyone! Our next task will be to create the inverted bar chart showing volume versus size. See you in our next video, and thanks for watching. Welcome back. It's time to create the second chart for our Drinko report. This visualization will display the volume of different package sizes for purchases of the products sold by the company. So let's double-click on the volume category and then go to Size. Tableau creates a regular bar chart. However, for our report, we'll opt for an inverted bar chart, which is referred to as a horizontal bar chart in Tableau. Let's open the Show Me menu from the top right corner in Tableau and go to Horizontal Bars. We confirm our choice, and voila! I'll close the Show Me menu to be able to see better. Great! You should know that this type of chart is particularly useful when comparing different sizes. Besides, Tableau allows us to order the bars depending on their size. If we go to Size and select the tiny arrow, we can order our bars alphabetically or by size. Let's try the second option. You could choose a decreasing or increasing order. To do that, just click on the bars next to Size. For the report, we'll choose a different option though. Let's click on the bars next to Size again, thus reverting to the original order. We'll order the bars by increasing bottle size. Simply click on the bottle size, say 250 milliliters, as it is the smallest bottle size, and drag it to the top of the chart. Excellent! It's time to go ahead and reorder the remaining categories on our chart. So the next one is 500 milliliters, then followed by 600. This is my preferred option for ordering this chart, but you could also stick with the default ordering provided by Tableau, which is alphabetical. Cool! We'll have an additional lecture on styling when we complete the dashboard. For now, let's bold the title and call it a day. See you in the next lecture, and thanks for watching. Hi again! In this lesson, we'll proceed by creating the third and final chart of our dashboard. It will provide information about the volume of purchase by client type. Let's see. If we simply double-click on volume, it will appear in rows. And then if we double-click on client type, it will be shown under columns. Excellent. We've obtained a bar chart. Once again, though, we'd prefer to have horizontal bars. We could change the chart type from the Show Me field as we did earlier, but this time we'll try a different option. If we switch the places of the two variables, we'll obtain an inverted bar chart. Makes sense, doesn't it? Volume is under columns, while client type is under rows. Alternatively, if you have a clear intention of the type of chart you'd like to create from the get-go, you can just place the appropriate data features in their intended place. In our case, we can directly drag volume to columns and then bring client type to rows. Regardless of which option we've chosen, the result is the same. We've now obtained a horizontal bars chart, showing the amount that was ordered by each client type. The types of clients we've got are supermarkets, grocery stores, discounters, and big box, referring to physically large retailers, commonly part of a chain of stores. Cool. We finish off by putting the title in bold so that it can stand out a bit more. And we're ready to add key performance indicators, which is the topic of our next lecture. See you there! Now that we have created the three charts, we're ready to add the pre-selected KPIs to the Tableau dashboard. As we said in the beginning, our report will include two key performance indicators. One showing the average discount offered to clients, and another one tracking average distribution cost. Let's start with the average discount in percentages. To obtain the value, we must divide the entire amount of discounts by the sum of gross sales. This means that we need a calculated field. To create one, go to Analysis and select Create a Calculated Field. The average discount in percentages is then calculated as the sum of discounts over the sum of gross sales. Remember that we need the sums here to make sure we've summed up the values for the entire month. Cool. Now let's check what our new measure contains by double-clicking Average Discounts in Percentages. Excellent. Let's convert the discount to a discrete instead of continuous measure. Cool. Since the values we obtained are in percentages, we ought to right-click on that number in our table and format it as a percentage. The menu on the right allows us to do that. While we're at it, we can align the number to the center and apply the same alignment to the text above. Great work! We can now proceed and add the second KPI, which, as you probably remember, aims to show the average distribution cost in percentages. Again, we'll rely on a calculated field. Average distribution costs in percentages. Then for the calculation itself, we only require the sum of distribution costs over the sum of net sales. Let's confirm by pressing OK. Now, if we double-click on the newly created field and then change it as discrete, we'll see the average distribution cost throughout the period under Analysis. Of course, we should format this figure as a percentage too. Great. Let's extend it to the right to make the text easier to read, and we can also align the text to the center. We can go ahead and bold the text as we did earlier. And that's it. Great work, everyone! We've obtained all the elements to finally start putting the dashboard together. Can't wait to do that. See you there, and thanks for watching. Welcome back. We're finally ready to create our dashboard. Let's switch to the Drinko Report dashboard and make sure we've closed the Format menu in case it's still open. Okay. For starters, we can define the size of the dashboard. The arrow that you see here allows us to do that. If we click on it, define minimum and maximum values for the height and width of the dashboard. In our case, let's go with 1400 for width and 1000 pixels for height. Whether these numbers are suitable might depend on the resolution and size of your display. Cool. Right under the Size panel, we see the sheets that we've created, 3 charts and 2 KPIs. And to create our dashboard, we'll drag each of the 5 sheets one by one into it. Let's start with the combo chart. Simply drag it to the field in the middle. Very well. Next, as we've discussed, our volume by size chart will be below the combo chart on the left-hand side of the dashboard. If we drag it toward the dashboard and hover, we observe that Tableau gives us different options for the position. Let's add it to the bottom. Excellent. The next chart is volume by client type. We position it to the right side of the volume by size graphic. So far, so good. Now it's time to include the KPIs to our report as well. To achieve this, first we add the average discount, and then the average distribution cost KPI. Great. Our report is almost ready, but it is still missing a key component. We should add dashboard filters. If you recall, the first filter we planned to have was a brand filter, while the second one was a date filter. Let's go to the net sales and gross profit sheet. Technically, you could go to any sheet, as later on we'll connect the filter to all of them. Okay, in the Dimensions panel, we can double-click on Brand, and from the drop-down menu, choose Show Filter. And here it is, the brand filter we need. Excellent! Tableau also allows for filter customization. For instance, we could go with a single value drop-down list. Let's try it out. Cool. Now let's go back to our dashboard and turn our attention to the net sales chart. If we click on the small arrow on the right, we'll see a drop-down menu appear. In this menu, we can find the Filters option where we're able to select the brand. Great. Let's see how this works. We could try the Multiple Values drop-down list option provided by Tableau. With this feature, we're allowed to select not just one, but multiple brands simultaneously. Our data is then automatically filtered to display information only for the selected brands. That's excellent news, but what about the rest of the dashboard? Isn't the point to make all elements of the report dynamic, adjusting altogether when we make a specific selection? Let's see. If we click on the arrow next to the brand filter, we can go to Apply to Worksheets. From here, go to Selected Worksheets and check all remaining sheets we've inserted to our report. This way, we make sure our filter is connected and will be applied to the remaining sheets as well, instead of acting on its own and filter only the original chart for which it was created. Amazing! I encourage you to try out other options for the brand filter on your own after this lesson. Next up, we'll be adding a time filter to our dashboard. See you there! Hello again! In this lecture, we'll add a date filter to our report. Let's go back to the sheet where we have the net sales chart and begin. Alright, to create a time filter, we'll need a start and end date, which will let us control the period of data we're examining. As our data source contains monthly data, we will also aim to filter monthly values. In the Dimensions panel on the left, we see the date variable. If you'd like, you might want to go to the data source and examine the values contained in data in more detail. In our case, this variable shows the month and year for which the data has been collected. Now let's head over to our chart and right-click on the Date feature we were just examining. From the scroll-down menu, we opt to Change the Data Type. At the moment, the date is regarded as a simple string. In other words, it is plain text. However, we'd like it to convert to date format. This is an essential step when working with time series data, so make sure to always have your time series data in the correct format. All right. We can now go ahead and create two parameters for the start and end date. These will be the first and last months in the report. So by changing the start and end date, we'll be able to control the time frame under analysis. Makes sense, right? Okay, let's continue with the start date parameter. From the right arrow next to dimensions, we can choose to create a parameter, which is called start date. Then, the type of this parameter will be date. Next, from the allowed values, we opt for a range. Okay, now there is an additional menu where we're able to select the range of values for our newly created parameter. Naturally, we'd like it to be in the range available in our data. If you recall, our data starts at the beginning of 2019 and finishes at the end of 2020. Luckily in Tableau, we can obtain these values by setting the min and max value from the field. As for the field itself, we've only got one feature of the date type, which is date. All right, the date range has been altered from the beginning of 2019 until the end of 2020, which is precisely what we wanted. Excellent news! Now let's alter the step size to be 1 month, as we have monthly and not daily data. Confirm with OK. Great! Now we can find the start date in the newly created parameter panel right under Measures. We're doing great! We've created the start date, which means we can move on to the end date. Let's first create the parameter for end date. Just like last time, instead of float, it should be of date type. Here we set the current value to December of 2020. We'll be able to change it later on, of course. Once again, for the range, we choose to set it from the date field. Don't forget to increase the step size to a month. Not that the filter wouldn't work with the default day step, but based on our data, it's unnecessary. Excellent! Our parameters are ready, which means we can link them together. To do that, let's go to Analysis and opt for Create a Calculated Field. It will display our date range. To make sure we're always in the correct range, we'll say that our date must be greater than or equal to the start date. At the same time, it must be less than or equal to the end date. We don't need brackets in the equation, as the relational operators, like greater than or equal to, take higher precedence than the logical operators, such as and, or. A bit of evaluation order trivia there for you. Okay, moving on. We can now drag the date range onto the Filters panel. Let's make sure it's active by checking the True box. Now we right-click on the start date and show the parameter control. Then, repeat the same action for the end date too. Excellent. Let me just move them to the left-hand side of the chart, and we can test our brand new filter. How does that sound? Now, with the help of the start or end date, we're able to filter the time frame displayed on our chart. Amazing! Such time filters are truly one of the highlights of the Tableau software. All that remains is to include the filter to our dashboard. Let's head over there. You can see that our combination chart has already been altered. From the arrow next to it, let's add the date range filter. Let's also include the parameters for start and end date. You already know that for a filter to apply to the entire dashboard, it must be connected to the separate sheets. So let's apply the date range filter to all of our dashboard worksheets. All right, this was the single more technical part of creating the dashboard. In the next lecture, we'll concentrate on chart styling. See you there! Hi everyone! Welcome to the lecture in which we will style our Tableau dashboard. So far, our main goal was to make sure the mechanics of the report were working properly, so we haven't invested time in improving the actual appearance of our charts. Time to change that. We begin with the date range filter, which would look much better as a single value drop-down menu. The next thing to do is to check whether there's anything unnecessary on the dashboard. For instance, when looking at the KPIs, we don't need their titles on top. The same information is already contained in the table below. So we right-click on the title and then hide the title text. Same goes for the second KPI. Good. Let's increase the size of the two horizontal bar charts. To compensate for that, we can decrease the KPI charts. After all, they contain a title and a single value, so they don't really need this much extra space. Okay, now we can increase the size of the bars by dragging them down in the following way. We can drag them to the bottom of the chart. The only issue I would like to avoid is the appearance of a scroll-down bar. This would mean that our visualization has become too large for its designated space on the board. Great! One of my favorite parts when sorting out the final touches of a data visualization I'm working on is deciding on the colors that will be used. For this dashboard, we'll use several of the 365's brand custom colors. Let's begin. We'll start with the combo chart and head back to its sheet. Here we can select Color from Marks and then click on Edit Colors. For the gross profit margin measure, we'll apply an orange color with a hex code EE4F23. While for net sales, let's go with a blue with hex code 108999. Good. Let's confirm with Apply and then press OK. Excellent. Moving on to our second chart, which shows volume by size. For this chart, we'd like to use different colors for each of the bars. However, achieving this is a bit tricky in Tableau. If we take a look, we'll see that at the moment we're allowed to choose a single color only. Not to worry, we'll use a workaround. To include individual bar colors, let's right-click on a bar and select Group. Now we've obtained two distinct categories, one for the first bar chart and one for the remaining colors. And as you can see, we were able to add two separate colors. Let's proceed with making each remaining bottle size its own group and then custom choose with respective colors. A bit counterintuitive, but there you have it. Right now, our chart is way too colorful. So what we'll do is choose a mixture of blue and orange to remain consistent with our combination chart. Let's go to Colors and then Edit Colors. We start with 1.5 liters and we alter the color to a very dark blue-green with a hex code 005559. Next up is the 1.25 liters category, which will be assigned the color code 11889A. For the 1.75 liters category, we're aiming for blue with hex code number 70B8C2. So far, so good. The fourth category, which is 2 liters, will be assigned an orange color. Let's enter the combination FBC570 and click on OK. 250 milliliters is again an orange color. Number FDD99F is the code, though in fairness, that's more of a peachy tone. but we won't get bogged down into too much detail. Instead, we'll choose the last orange color for this graph. Let's try it with F9 9F10 and press OK. Five down, 3 to go. We're back to the blues, and for the 600 milliliter category, the hex code is 66999B. Cool. The second to last category is one with the color code 0D7984. And finally, the 2.25 liters category will receive the lightest blue color for this graph. CFE7EB is the hex code to achieve this. Let's confirm with Apply, and then click OK, and voila! Our chart is ready. The only remaining chart that needs our attention is the volume by client type visualization. Luckily, we've had a bit of practice and can adjust the colors for this chart in no time. First, we must right-click on each category to make it a distinct group. Great! Now on to colors. And we start with Big Box. 6CC4C2 is the hex code for a turquoise. We follow it up with an orange color with the hex code FBC570. Okay, let's see the next category. F9 9F10 is the code for a bright orange color. We used this precise color in our previous chart as well. You can add a color to your custom colors and reuse it whenever you like. This saves you the trouble of remembering and typing hex codes so often. Which leaves us with the supermarkets category. 11889A. This is a blue color we know all too well, as it's the 365 Data Science blue. Let's apply the changes and observe the result. Marvelous! Now that's a dashboard worth presenting. The only thing left is to examine and interpret it. It is a very good practice to do this a few hours after you have finished working on formatting and dashboard creation. The reason to do that is that you'll have a fresh perspective and will be able to see any inconsistencies or details that need to be fixed. Having said that, I'll be happy to see you in our next lecture. We've done the hard work. It's time to take a look at the end product of our work and interpret the data. Shall we? The different charts we added to the dashboard allow us to track different aspects of the company. First, we're able to see the evolution of net sales and gross profit margins, which helps us determine if our company's growing sustainably. Then, we're also able to see the breakdown of sales by type of client as well as by product size. Not to mention that with the addition of the time filter, we can observe the company's development on a monthly, quarterly, or yearly basis. Perhaps one of the most valuable parts of the dashboard is our brand filter. It allows us to increase the granularity of our report and examine the performance of a single or a few brand or brands. This way, we're able to answer key performance questions such as which brands are doing well? Are there brands that are losing us money? Are there brands that aren't growing fast enough? And so on. Even more than that, our report could help us improve our numbers in the months to come or help us come up with a new strategy at a total company or brand level. For instance, say we wanted a report on how the Drinko company has performed in the last 12 months. We'd simply adjust the start and end date to show the last 12 months of data. But we could be even more specific and look at a specific quarter, not the whole year. We could check the data for Q1 2020 and see whether our sales quotas have been met. Again, we simply adjust the start and end date. In this scenario, our data shows the first 3 months of the year only, so we can analyze numbers related to this period only. Another way to refine your analysis is by filtering by brand. The brand filter allows us to examine the performance of an individual or a group of brands within our company. This would be useful if we have made a new acquisition, say Evan Water. Then we'd be interested in tracking the development of the brand more closely. Moreover, if we acquired the brand 3 months ago, we wouldn't necessarily have data going further back in time for this brand. With the brand and time filter, we're able to zero in on specific parts of our company's development and stay on top of many different processes. Without the filters, we see the aggregated data, which is valuable but isn't the only aspect we're interested in. Excellent. There is a variety of options you could explore with a dashboard, like including additional features to your report. Why not add more KPIs or an additional slicer? Remember that each business is unique and requires a well-tailored and specific strategy. Ideally, a dashboard helps you answer the questions of the management when they're making business decisions. Moreover, your strategy and goals might need to evolve and change over time, which means that your report will change accordingly as well. And hey, don't be afraid to explore ideas and concepts beyond what we've shown here. I bet you'll come up with some amazing stuff. Good luck, and thanks for watching.